Hi all, this is Claudio from FEA.com with the new live stream regarding and containing finite element analysis in ANSYS Workbench. Let me share my screen. Today we're going to develop and let's say deepen one of the simulations that I made 12 years ago. And yeah, I kind of forgot about it, that it needs improvement. Let me show it to you. It is this. I have named it trial. In the end of the title, there is the suffix trial, because it wasn't my best simulation, let's say. It was just as it is named, only trial. There is some collision. The wheels kind of spring back, and yeah, there is a lot of improvement. So after 12 years, lo and behold, we are going to improve this simulation. So let me go to GrabCAD. I have seen this model. Let's make it work, you know. Let me open SpaceClaim. Until then, a quick reminder about my website, FEA.com. I have updated it. It has a new, let's say, coding engine. I have used some AI in order to optimize this. And yes, books, tutorials, FE support. Just give me an email, pay some money, and immediately, maybe even in a few hours, I can help you get unstuck from where you got blocked in your simulation. My support is easiest to be applied, and my advice is easiest taken by students and people who sustain their thesis and they need a simulation part in their final dissertation. So I am here for you. I think I have downloaded this. Let me drag and drop. Nah, it's an assembly. Come on. I should have downloaded the entire folder. Yes, it is here. It's pretty simple. So in the beginning, this is what we do. Yes, we start with simple assemblies, simple approaches. Until the 3D model opens, I will let you know that we will approach this from a perspective, because we will not have the so-called convergence issues. Let's kind of simplify this model. I mean, let's delete what we don't need. Do we need the steering wheel? Huh? Of course not. Pull up to this face. All right. I do have some radiuses, which sincerely I don't care about them. Let's go and hopefully delete them. selection, all rounds, delete. And then I should remember to scale all these. Because after all, it is a toy car. Delete. All right. Delete and delete. All right. Can I make this not hollow, something like this? Also, hide others. What do I need about this? Cecilia, we don't care too much because, yes, it's repeated. It's a repeated part. Can I dare to delete these radiuses? Of course, pull up to this face. All right, we're kind of on the right path, we can see, regarding the simplification of this 3D model. Come on. Pull up to this face, show all. Now my intention is to kind of make some Boolean operations, design, combine, with control pressed here, 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 here. Does it work or not? Let's see. Hide others, and let me make this transparent. I left this inside. Let's see if I can delete them. No. Then Control Z. Control Z. All right. Delete, right click, select depression, delete. Show. Now, up to this face, for example. All right, and now we don't care too much. Combine with control pressed. All right, so triple click, it's a single bar. Let's now think about the wheels for a second. Firstly, any message from our, oh yes. Hi, Anita. Hello. Welcome to the stream. And stay tuned. Maybe you'll learn some new ideas, new approaches for your project. Feel free, by the way, to ask questions. Yes, this is why you're here. So benefit from my dozens of years of experience in FEA. So where were I? I will kind of select this axis and choose section mode. Oh, the assembly is so well made, so well made. Cecilia, I do not need this channel. I am glad that I can use this outer part as a tire, as a rubber tire, this outer part. This is nice. This will be like a rim, a metallic rim. Only I would like to make something. Let's hide this. No, inverse visibility. Let's make this diameter a little larger, because at a certain point I might get rid of the contacts and maybe use body interaction. No, I meant get rid of the contacts and body interaction and maybe use joints. Yeah, you will understand in a few minutes. Show all. So I do have here a gap, also here a gap. I would like also to have here another gap, but on the wheel. So let's write minus 0.05. No, 0.1. 0.05, all right? Why I said this? Because I would like also here to be 1.55. All right. Yeah, gaps everywhere. And I will repeat this section view. Look here. I'm clicking this axis and going in section mode to see that we do have a gap. Also, we need here a gap. I will choose this face because this face pertains to the wheels. And when I modify one wheel, all four wheels will be modified. So let me assign here minus 0.05. And we have the gap. Always take care about some gaps, all right? Because you don't need perfect touching, let's say. Oh, car designers. Look at me. Car designers. Now I would like to see about these. I don't like these lamellas too much. So let me see if I can somehow fill these. Can I or not? I'm thinking about the easiest way to do it. I don't think we will find an easy way. Let's just make a rectangle, all right? It will not look as attractive as it was before. And this, I will click on this. We have revolve, and I'm clicking on the axis. And I will write from the keyboard 360, all right? It is an additional body. So now we can go with design combine, and this is what I have. Let's make the chamfers. Let's make them again. Pull, chamfer. How much? Superb. Now show all. We have the same for all. All right. This part is made out of rubber. It's important to make it out of rubber at this moment because we will have a road with obstacles. So let me see if I can appeal to one of my old models. Look here. Because I already have a street, you know. All right. So in principle, this should start from somewhere here. Yes, let's extend this. Click here and pull here. I can see an inclination here. Look here, here is touching and here there is a gap. So I would say let's rotate it with 0.5. Yes, almost. Even one? No, 0.35. Yeah. Perfect. Now we're going to pull with 10 and here again with 10. All right. So, ladies and gentlemen, we do have something like a 3D model. Let's make some windows just because it is possible. We do have a project to sketch. This one, this one. And this one, and we do have an offset curve. And I can select all these curves, and I can stop whenever I want. 3 millimeters. All right, this segment is not useful. Delete, 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 delete. Because it's so hot outside, we definitely need a window in our car. Should I make it as big as possible? Now, we do have this command, trim away, and we're going to get rid of what we don't need. Let's make also windows for the passengers in the back. Why not? Pull, yes, and where we just drag. We will select these parts, hide others, because we want only to cut here. All right. Pretty nice car. Get ready. Can I make a chamfer here? Oh, oh, so professional. All right. So this will be the first variant of the car. Because I would like also to, if I have the time, to also make something resembling a suspension. So this is live stream 29. Simple car plus road V1. With obstacles, plus road with obstacles V1, stream 29. All right, now, do I need this thing? I think I would like to pull it up to here, no merge, up to here, and maybe this is all. The purpose of this live stream is FEA, yes? So this is why the 3D model is not the best. This is the road. Right-click, delete empty components. Right-click, source, internalize all. And I have, this is the car body, this is the road. Oh my God. All right. Let's relax a little bit for we're doing something we don't want. So safe. Let's open ANSYS. Any question from the audience? Sir, would it be possible for you to add the slope to the road? It is possible, only it will complicate things. I will assign a small inclination, and I will tell you how the things get complicated. I will assign a small inclination, no problem. Three degrees should be enough. 2 degrees or 3? Let's make it 2 because I can already predict what will happen. Pull. Yes, but if I do this, if I rotate it, there will be no inclination anymore. Let's leave it. There will be gravity. Let's leave it like this at the moment. I am going to create like something like a dummy rubber, let's say. What I forgot is to scale. Let's make this kind of realistic. So the length, instead of 60 millimeters, let's make it 2 meters, yes? So 120 scale. Pull, scale, an anchor point, and I will select what to scale. I said 120 to have what? I don't want to scale. Let's scale separately. Pull, scale, pick an anchor point. 120. Does it work? No. Why? Why doesn't it work? I do presume there is a problem with the pattern. There is a pattern here for the wheels, and I think we need to assign independence. So look here. Let's just try. So right click, make independent. Right click, source, make independent. All right, here right click, source, make independent. Here right click, source, it's already independent, and there is no more dependency. Now let's try and do that the scaling. Pull, scale, let's choose a point, 120. What do you know? Why? Should we ignore it at this moment or not? Let's see if I can. I should be able to scale it separately. Come on. Yes. Yes. I'm scaling part by part, let's say. It is pretty laughable. I will see in the end what the problem was. What the actual? All right, you know what? We don't care too much. Ah, huh? Oh, yes, I had some dependency left. Yes, there was some dependency left. All right, now, do I dare to scale all parts? Yes. So look here, the width, yeah, it's almost 2 meters. All right. Source internalize all, delete empty components, save. I am going here. I promised about some dummy rubber, so look here. 1,000 kilograms per cubic meter. Young's modulus for a hard rubber. We can ask AI, why not? Let's ask AI. Young's modulus for a hard rubber. 10, 2 to 4 gigapascals. Hard rubber. Almost ebonite. Oh my god. Let's make one gigapascal. So we're changing the units to 1. And of course, the Poisson ratio should be close to 0.5. Heat constant pressure, we don't care about this. We do have something like a rubber. This street will be made of structured steel. Let's import. Let's copy paste the name. The name is this one. So if I have this inclination, the first thing that we'll need to solve is the falling of the car towards the horizontal. Let's see. If it will not work, I will get rid of the. I'll make the road horizontal if it will not work. Come on. So firstly, we need to define standard earth gravity. How much? What axis? Y? What? Minus y-axis. I hope you do see the axis. Do you see the axis? Yes, you see it. See it here. Yeah, we let's leave the road. This is tire, let's say. Yes, you see here Guma. In German, Gumme is rubber, I think, or even caoutchouc in German. I would like to rename this because I do have rims here. The rims will be made of structural steel, while the tire will be made of the rubber that we defined. The road is made out of steel, car out of steel. Okay. We do have pretty heavy assembly. Oh my God. The road is how much? Let's see this chunky car. How much does it weigh? If it's possible, of course it's not possible. So the total is 400,000 kilograms. Oh my God. Can I change to tons? 400 tons. And this is the car. The car is 400 minus 168 tons, 200 tons. Oh, this is a pretty heavy car. Of course, because, you know, the body in white, the car body, everything is hollow, yes? We do have a chunky car. After all, it will be a proof of concept. Nevertheless, if we're here, let's, instead of structure steel, let's assign aluminum. Why not? In order to not be so far with our assumptions. Right-click, refresh materials, and I will select where we have question marks. I will replace with aluminum alloy. For example, now we have 140 tons. The road is 60 tons, so our car is only 80 tons. It's a good locomotive here. All right. Having this much weight might impact the so-called tires. This is why I also wanted them to be filled, not with those ridges, those lamellas from the beginning. What is this? What is this? Design. So it didn't scale so well. Let's remake the Revolute mating here. So how do we do this? Assembly, align. Geometry to align to the peak reference. What? All right. I think we're in luck. Perfect. And I think it is the same also in the back here. No, we need to align here. Assembly, align, whatever they're saying. Let's see if I have the proper alignment here. I will hover, select the axis, design, section mode. Perfect. Should I or should I? Let's make this a little more. a little more hollow, if I can say. Mhm. I don't want sincerely to pull this towards here because I will obtain a very small mesh, very fine, where we'll have very small elements here, and it's not my desire to do so. Let's be satisfied with what we have. Save. And here in our window, I will update geometry from source. So if you all are getting bored and you don't have the patience to look, to see, to understand the modeling, the approach, the meshing, the matings, the discretization, the analysis settings, feel free to skip until the end when you see the results, but you will be missing the details for the simulation. So nobody is forcing you to stay with your eyes glued on your laptop or whatever computer screen you have. So let's delete the contacts at this moment. Can I check the weight once more? 150, oh my God. The road is 60 tons. Whoa. All right, let's revert to millimeters. I would like to fix this road. Click here and fix it. Do you have any questions from the audience? Sir, would it be possible to increase the distance between the humps so the vehicles can translate a flat road section after passing and then encounter another hump? Yes, it would be possible, of course, but in the future designs or simulations, okay? They are too frequent. Yeah, it's SpaceClaim is open. I sincerely don't want to make exactly everything what everyone is saying. I hope you understand what I'm saying, because afterwards, yes, it's not me doing the simulation. It seems that someone else is doing the simulation. Yeah, it was easy to delete here. Let's save and update again. Update geometry from source. All right, so this is the model that I'll be going with. I do have a gap, a pretty large gap. An easy way to move parts is to go for the part transform. I will select the road, and I will say translate y how much? I don't know, 100. Oh, it's good, 100. Right click transform, and let's mesh. I will deal with the body interactions later. Here for mesh, I will choose capture curvature now, and for quality, I will choose smoothing low to have a very coarse mesh. The focus will be on the FEA to make it work, not on the refinement and other stuff. So coarse, but not so coarse. Instead of 493, let's choose, I don't know, 350 millimeters. All right. $300. 6,000. All right. If I stay within, I don't know, less than 10,000 nodes, it will be very nice. $9,000. Where I want a fine mesh? I want a fine mesh on the tires. And you know what? Let's Control A method. Tetrahedrons. I said I would like a finer mesh on the rubber parts. Sizing. I don't know. Let's make 200. I think we might need to 150. I think. Oh, very nice like this. All right. Let's look in a section view why. This wheel is too complex for my taste. For example, I don't like having this up to here. All right. Should I keep these or not? Let's keep them. Now they are independent. This is why I need to do the same thing 4 times. Let's select the rim this time. So when we have such an it's not inclined. Okay. Yes. Update geometry from source. Remember that for each geometry update, the contacts are remade. Yes, just saying. $10,000 nodes. It begins to look as it should look. Let's assign a section view to see what happens in the shaft of the rim, where the rim it will be mated. Look here. So it looks perfect. The mesh is very nice. I do have a gap here, but I don't have a gap here. Let's go in SpaceClaim again and verify the gaps. I do have gaps everywhere. And here I don't have a gap. So let's pull and hit minus 0.05 multiplied with 120. I don't know, 0.6. No. -6. Perfect. All right, let's check the gap again here in the back. We do have proper gaps only here. -6. And here, yes, we don't have a gap. -6. Perfect. All these details, no matter how unimportant may seem, they are very important. We should always pay attention and be sure 100% that we have the most perfect geometry, if I can say it like this. Most perfect geometry. Yes, I'm an engineer after all, so please excuse my French. I'm not sure that the mesh is, yeah, you see, it's kind of hexagonal. If I remove the, look here, it's hexagonal, yes. And the problem with an hexagonal mesh is I cannot properly define a revolute joint. I need to have something closest to a circle or to a cylinder, let's say. So what there is an easy way to assign another to refine the meshing for this. Let's do just this. Maybe 200. Let's look on the, it's still a hexagon, all right. So this is how it's going to be. Let's only select the rims, hide the other bodies, and I will refine, select face. I will refine only these faces. 150. Look here how they look like now. So they are going much closer to a cylindrical shape. Let's go even furthermore with 100. Yes, so now we can say we have something resembling cylinders, all right? Invert visibility, I would like to do kind of the same here for these shafts, because they will be mated with the inner faces, with the holes from the rims, you understand? So sizing, 100 again, and we will have perfect mesh match, if I'm allowed to say this, yes? Show up. All these will be very easily understood once I make this section plain. Look here. You see, we do have something resembling circles or so. Here we don't care too much about this interface because we will have kind of bonded contacts. Normally it will be a bonded body interaction. This is why I don't care about mesh. I only care here. So let's judge a little what's happening. The friction coefficient. There is a default body interaction, frictionless between all bodies. I will leave this. I will not touch this. What I would like to assign is a frictional body interaction between the rubber and the road body interaction. This will be frictional, and the friction coefficient, I remember, is something like 0.5 or whatever. Now I can leave all contacts like this, except what I forgot. I will assign the bonded interaction between the tires and the rims. I can do extra work and select them, assign the body interaction in pairs, 2 by 2. But because I know this body will not touch this body, will not interact with this body, will not interact with this body, I can select all of them, body interaction, these, yeah, and assign bonded. Because I know for certain they will not be touching, so I can do something like an overall contact, let's say, or body interaction. Let's get a feeling of something like an offset. For example, I'm interested in this gap. You see there is a gap and there is a collision. And I'm interested to see the distance in this gap. I think the maximum distance is around maybe 10, 7. So something to cover everything, I will assign 15 here for maximum offset, 15 millimeters. In order to make sure that all nodes from this from the rims will perfectly touch, will restrain all nodes from the tires. So in principle, this is what we have. What will need to happen is we will pull this, we will make it work. But how? I will make it work about the x-axis, which is perfectly horizontal. Because if I make it work about the slope, then there is no interaction, there is no worst condition of the slope. So I need to make it perfectly vertical, and it will encounter this slope and the obstacles. I'm interested to see here in the back what will happen. So now let's go in the sign. I don't know. This is interesting. We'll need to make a calculation like this. The amount, the length of the road that will be traveled is this one. Let me make it in meters to easily understand. So the car will travel around 10 meters. Yes? And we need to make a calculation. If I will, for example, I would like to, those 10 meters, I would like to be traveled in, ideally in my mind, in 0.1 seconds to have a faster solving simulation. This will mean the speed will become how much? So, and x equals 10 meters multiplied with 1 second over 0.1 second. We simplify here, and we have the results in meters, yes? So it's 10 over 0.1, which in my mind, I think it's 100. But we can make sure. 100. So the speed will be 100 meters per second. This is what we have. We have 100 meters per second. The problem is that these 100 meters per second are equivalent to 360 kilometers per hour. This is the problem. I will answer to your question, Muhammad, in a minute. So look here, 100 meters per second is 360 kilometers per hour, which is not funny. Because, why it's not funny? Because it will kind of impose some shocks, and it will destroy the rubber, it will impose some shocks. But let's stick with what we have, yes? So 0.1 I promised I will answer what Muhammad asked. Muhammad asked, how many years have you been using us? Oh, I think around, it's hard to say because I firstly installed ANSYS in the year 2000 and I have used it on and off since then. But professionally, I'm using it since 2012. When I was hired, let's say, my job was only in ANSYS or bench. So I can say that I have professional use of around 14 years. But I also worked with Nastran and Patran and some Cosmos Design Star, which was implemented into SolidWorks simulations in the recent years. So I have experience in more software, let's say, packages. And I have always used ANSYS Workbench even before the year 2012, when I was interested in an easier finding of solution of results because of the appealability of the attractiveness due to the easiness of usage, let's say. And the GPU, I don't think I use it explicitly. The GPU is this one. It's RTX 58. I would say my main, how do we say, pièce de résistance is the processor, yeah, 64 cores, physical cores. So yeah. I recommend ANSYS because it's very easy to acquire, to understand, to learn, compared to Abacus, Hyper, Works, whatever. They require lots of dedication and trainings, but in ANSYS Workbench it's very easy and attractive for beginners. So I would advise everyone and anyone to start with ANSYS Workbench. Then hopefully continue with ANSYS Workbench. 1e minus 6, 1e minus 9, 1e minus 6. Let's assign some timesteps. Because we do have some linear materials, we can be daring in assigning some mass scaling, yes? Or advising this mass scaling. Sincerely, let's make retain inertia no, and output controls maybe 100. Result number of points. All right, we have this. Now the proper load, we have two. We have two options. I can apply a velocity on this carbide, let's say, or I can apply displacement. Look here, displacement and on the carbide. Extend connections. There are two different things. If I apply the displacement, you remember 10 meters. If I apply the displacement, there will be a restriction on the x-axis. If I apply the velocity, knowing that I have 100 meters per second, yes, I can apply a velocity. Look here, components, 100 meters per second. The problem is if I apply velocity, I will have some loose parts. There will not be any restrictions, let's say, on the parts. At this moment, I sincerely don't know what to apply. So let's suppress here the displacement and check the differences. All right, let's delete the contacts. And I assigned this interaction. I didn't assign the interaction between the shafts and the rims. Let's assign them. At this moment, I would advise to have these kind of joints, Revolute joints at this moment. So there will be this joint. There will be this joint. There will be this Revolute joint. And there will be this Revolute joint. Now, let's invert visibility and assign what we have, yes? So for this one, we will click here. For this one, we will click here. For this one, we will click here. And for the last one, we will click this face. Now show all. And you can see now these Revolute joints. They are present here, here. You can see them. This one with this one, yes? Here. Simply, all right. Yes? And here. So we have revolute joints, all right? Because we have revolute joints, I can kind of forget about the sizing that I have given. You remember, I have assigned a sizing. Come on. I have assigned this sizing. This sizing would have been useful if I had a contact here, but I'm not interested in this contact at this moment because we're using joints. When we're using joints, the joints are related or they are referenced to the geometric features, to the topology. It's like a theoretical referencing. So the joint will not care about how the faces touch. These joints care about how the axes are aligned, and they need to be coincidental. For example, this z-axis is coincidental with this z-axis. Look here, rotation about z, z, z. Let me zoom in. Yeah, this is what they don't care about, the shape of the face. They know from the geometry that the shape is intended to be, and from SpaceClaim SolidWorks CATIA, it exited as cylinder, as revolute surface. Yes, this is why at this moment I don't care about the meshing. I can leave it hexagonal, you know. Let's remake the mesh. Look here in section view. Section view, you don't see the fact that it's hexagonal. And the easiest is to look here. It is hexagonal, but we don't care because if I click here, you see it's a perfect circle. If I click here, it's a perfect cylindrical surface, which is used in the definition of the revolute joints. This is the biggest difference between heavy contacts and the joints. Joints are referenced kind of theoretical, using axes and centers of mass and whatever, gravity or usually geometrical coordinate systems from the mass of that body or part or feature, whatever. While the contours about how the mesh touches. But we don't have contacts at this moment. We do have some loose, let's say, body interactions. Let's give it a run with velocity and see how much, how many, how long it will take. I'm curious about the part in the behind. Yeah. Before solving, let's see if we have a question. How many years? Okay. Right-click switch to automatic mode in order to see during the solving how the FEA behaves. I'll take a look on my smartphone. All right, no message. $3,000 Oh my God. Oh my God. Let's make it 3 meters. Any question from the audience? Yes. Finally, someone answered. Your screen is not visible. ANSYS Workbench is not showing. Finally, thank you for the reply. Let me stop sharing and I will share again. Let's see what's happening. So this life is kind of lost, I would say. Can you write in chat, someone out of 5 people, can you write in chat if you see my answers? Please. Today, hopefully. Oh my God, why is this not showing? Oh my God. Now it's fine. All right, I'm glad to hear. Sorry for not being visible until now. No, you have seen there was no response from your colleagues. What I will do, I don't know what to do. There is a portion of maybe half an hour when ANSYS was not visible. Yeah, I think I need to cut it. Why it's not moving? Oh, hold on, let's see. So Anita, I revert to a horizontal road. I suppressed the velocity. Now I have a displacement. I made the axis 0. I only applied 3 meters. And the problem is the car is not moving. So what we do when something is not showing correctly, we go and change the scale, maybe to auto scale. Let me revert to flexible here. Extend limits. Maybe the rigid body dynamics is not properly solved or shown here. There is a problem. There is no rigid part anymore. Come on. It makes no sense. Let's make these two free because no. What is happening? I don't know what's happening with the simulation. I will put it here. I will come up with another explicit dynamics. I definitely need the geometry. I will need the materials. And do I need the mesh? No, maybe not. So I seem to have missed off the topic. Yeah. At this moment, I don't know what to tell you. So rim, car, aluminum alloy, tire. tire. Maybe rubber, road, aluminum alloy, contacts. Let's leave this. Then, what did I say? Between these and the road, let's assign 0.7 was. Frictional 0.7. Oh, by the way, Anita, pay attention to what I'm doing, yes? Because I'm doing from scratch, so it's nothing lost, yes? The last case, I am doing it again, so pay attention. Again, the rims and the tires will be bonded. Select all mesh method tetrahedrons. Generate mesh. Let's make the geometry, the road to be horizontal, parallel to the car body. Why it's not? I would like to rotate this assembly. Yes. Perfect. All right. Let's rename this V2 because it was heavily modified. And here, update geometry from source. Can I make this rigid? Let's see. We still have the hexagonal meshing. Look here, so this is unacceptable. So we need to kind of mesh them separately, let's say. Or we just don't care and we assign again the Revolute joints. Because the Revolute joints, the joints in principle, they don't care about the mesh, yes? So look here, hide all other bodies. I will start from here. So we ignored the mesh, all right. Why? Because I would like to have this number of nodes. I said we're going for 0.1 millimeters, 1e minus 6, 1e minus 9, 1e minus 6. All right, so I advise for mass scaling 1e minus 6 and maybe, I don't know, 15 for part scaling, no for inertia, and 100 for result number of points. I said that I would prefer to fix this road, and I would like to, if possible, to displace these faces. I'll not select all these faces because I do have some cylindrical faces which mate with the rims, and I think maybe there is a possibility that the displacement load maybe does not exist anymore. By the way, it does not exist anymore. Maybe the displacement load will interfere with the joints, with the Revolute joints, if I apply the displacement on all the faces, including the faces from which pertain to the Revolute joints. By the way, at this moment, look, displacement is back. I cannot use it because I do have a rigid body. And I was saying, what do we have? 3000 millimeters. Let's leave it like this at this moment. No 0, here. Do I care about the standard Earth gravity? Yeah, why not? Even though it doesn't make much sense. Right-click, switch to automatic mode. Total deformation, velocity, strain, and stress. All right, let's save and hit solve. Let's see if it works. So I made the scenario, the FEA from 0. Good news is it works. Only we need to resolve. Clear generated data, solve. Is the mesh density fine? It depends on what you want. For this case, for this proof of concept, for this live stream, where we want results in this live stream, not tomorrow or next week, yes. Will someone from the BMW, Tesla, whatever, use this mesh? No. So relax. I don't think in the 5 spectators we have engineers from Tesla or NASA or Space, or I might be wrong, but I think I'm completely right. So just let me tell you, working for an OEM, automotive OEM, right now, we do have specific, let's say, standards for meshing. For we should, yes, in our team, in our research, we should verify the mesh quality, and we should verify also we should make some convergence studies with the meshing, yes, and the parts, depending also on the parts. If we're doing some proof of concepts, some small verifications, we don't care too much. But if we're doing serious stuff for projects for done, yes, we're going to have finer mesh. It depends on what you need. And this present live stream is not a live lesson for any automotive or aerospace industry, okay? It's just to attract beginners in this nice field of finite analysis. And we attract beginners with easy stuff, quick results. So let's not ask too much when it's not needed, you know? To my extreme shock, let's say, this car does not move at all. Did I exaggerate here? Or it's the problem with the car being rigid? So let's make the car flexible. with Control pressed, we're selecting most important faces, let's say. Let's see if it works with the car flexible, because at this moment I don't know what is the culprit for the FEA not to move. Let me get out for a few seconds in order to close my blinders. Oh. All right. My water bottle fell off. The FEA goes, but goes where? Something seems to be moving. Come on. Yes. Finally, something is moving. So, note to self. Beware of rigid parts. Yeah, just remember. I'm having a really annoying performance problem with mechanic, even though my computer is super powerful. Yes, it looks like a good CPU. I'm wondering if you have SSD, NVMe SSD. But nevertheless, this is a good computer. Let's. You need, of course, you need to reinstall Windows. I think you need to clean it up. This is my advice. And rigid elements can move but can deform. I don't need to deform. Yes, so I applied a displacement here on this body, on the rigid body. I didn't expect deformation. I only wanted to move it horizontally. So I don't know why ANSYS didn't do. The first in contact, I think, is this wheel. The mesh is pretty awful, but if it works, I would refine the mesh. I would like to be certain that the FEA works. What I can tell you for sure... okay. It's good that I didn't make this... look here. This displacement, I didn't force it to be 0 vertically, because it is acting like a kind of a pseudo of a fake suspension here, because it can move vertically. Just saying, okay? Oh my God, finally we have some results. I don't know what happened with this. This didn't work. Let me delete it because I don't want to touch it at all. I'm curious if the wheel here will touch again the floor. It should, because it has the gravity. And the gravity tends to keep things in contact, yeah? Because the car should immediately fall off on the road, logically speaking. Who is flying away? So definitely we need to make the displacement on the y-axis, the vertical displacement, we need to assign it 0 in order not to have this bouncing and flying away. It might come down, but who knows, maybe here or here, who knows. The problem with having such a high velocity, yes, is that 3 meters per 0.1, around 120 kilometers per hour. The problem is that, yes, even in reality, there is a bigger shock and the contact is afterwards. Yeah, there is a big bouncing. So let's not wait for this. Let's pause it and I will duplicate it. I'm thinking, what if I make the rims rigid? What if? Any question from the others? All right, no question. So six spectators, welcome. I think it's my maximum. It's a new record. So let me give you nice stuff. What I was proposing is to make the vertical displacement 0 and also the z displacement 0, because sincerely we don't care. We don't need lateral displacement. You understand, right? So let's see. I was wondering, maybe instead of 3 meters 0.1, let's make 3 meters 0.2 in order to have a smaller velocity. Yes, we kind of divided with 2 the velocity. Let's save, then solve. What it's a little troubling, the sizes for these. Come on, let's make them even better. Size again, I said 0.2 if I remember correctly in the past. 0.2. It begins to look better. And also, I would like these faces, the touching faces, to be a little finer. 0.25. Where are we? 7,000. Yes. Let's save. Six people live. I will soon reach queso. Queso with 70,000 viewers. For the people who just joined, remember about this. Here, look here. I'm talking about especially mass scaling. Otherwise, you will solve the simulation in a few good hours, maybe 5, 10, 20 hours. Just take this into account. So, what should we show regarding? Did someone dare to make a simulation with tire? No. Yeah, this is interesting. This is interesting. Deformation of a pneumatic tire model. I remember this. This is nice, yes. I'm wondering where is the outlet? Clearly he has an inlet. The outlet is the inside of the tire. Pretty tricky, yes. Yeah, I don't know how correct is this, but yeah. If we are here, let me show you this. This is nice. Does it work? Yes, it works. We can clearly see now that the car is heavily restricted to the canceling the Y and Z components of displacement. What is this? 1 second, 1 second. I forgot to half on here. But you know what? Let's let it work. Yeah, let me show you what I had in mind. What I forgot to do. Here I should have had one. Maybe delete this, you know, and a 3 again. Only the speed will be very slow, let's say. Let's meet somewhere in the middle. Where was I? All right. So this is my first time, and I did it with coupled Eulerian Lagrangian. This is water, and this rotates, even though it's not so easily possible. I have modeled an arrow to see that it rotates. It was work. And then SPH was implemented with small bonds with smooth particle hydrodynamics. Yeah. Also with water properties. It's so nice, yes. Does it work? Yes, it works. So soon, maybe, I don't know, maybe in 10, 15 minutes, we'll close the live stream because it works as it should be, the FEA. And once we establish a nice trend, then we can stop the solving. And of course, whoever needs these simulations, these models, these files can ask them via email or wait a few weeks until I will publish them on expertfa.com. Usually I publish them here. Yeah, solve the FEA and CFD nowadays. So this was treated in a live stream. This is also treated in a live stream. Also this one. These three were made in live stream. In live streams, only these are optimized versions. I have closed the live stream, these live streams with the working simulation. And this, what you see, was in a few more days optimized. So it's better what you see in the live stream. In the live stream, we see the start, the principle, the proof of concept, the fact that it works. But afterwards, I'm optimizing them. Come on. So the first touch will be here. On this side, let's see. So the highest stress, of course, is in the stiffer parts, and the lowest is in the softer parts. We do have something like a rubber here to account for the tire. I think we are on the right track. Let's switch a little without wireframe because it looks nicer. And if you want to see the rotation, look at this cross, and you will see that it rotates. Many people, when dealing with such simulations, even though not many people treated such simulations, many people are hiding the elements, yes? So I'm talking about this, showing the elements. And they want to hide something, or something, they just show the edges. Oh, 4,000, oh my God. $5,000, why? Yeah, so the rubber is too hard, and it imposes such high stress in the rim, also on the road. But let's check a little. 400, it's not big. Yeah, no, it's not big. Where is the maximum? Maximum is in. Is in the, let's call chassis, okay? So you know what? Let's scope with 400. Yeah. So what I would do, advice for people watching, because I will also do in the next days or weeks, I would make the rubber softer, because in reality there is an air room inside the tire, yes? Not as filled as we have here. I have a solid model here. And the rubber has half the density of the ebonite, of the vulcanized rubber. So I would kind of create a softer rubber. You can see the rubber definition at the start of this live stream. And gradually I would use nonlinear materials for where I have metallic parts. So instead of aluminum alloy, choose aluminum alloy NL, nonlinear, from the engineering data library, which you already know and use. So the tendencies is very nice. What I would like to see, I'm staying until I see the rubber bouncing downwards, as we expect. Yes? Because let me tell you, assigning 0 on the y-axis, it's forcing the rim downwards. So it should bounce back downwards normally. This is my expectation. So for even better stress, make the metallic parts nonlinear and make a softer rubber. And you should definitely have smaller stresses. Yeah, so it bounces back as expected, and we can count this definitely as a victory. And to the person who asked about using the mesh coarse or should be finer than this, yes, feel free to refine it once you have the concept working. If we refine the mesh, as I have seen so many beginners, they make such an extraordinarily looking mesh, and the FEA does not work at all. If we refine the mesh without having a working scenario, the usage is 0 for that fine mesh, absolutely 0. When we have a working concept, as it is here, then we can easily refine the mesh with the expected extension of the solving time. Yes, expect for the solving time to increase. A software that doesn't care too much about the mesh refinement, I mean, does not extend the solving too much, is LSDyno. So if possible, try and familiarize yourself with LSDyno, because in LSDyno you can use very fine meshes, and the solving time will not extend too much. So, ladies and gentlemen, it bounced back. We have a proper passing of the obstacles, let's say. So we're on the right track with this model. Offline, of course, I will continue the simulation and I will publish it on expectfea.com. In the meantime, if you want these, let's say, these trials, these draft cases, I can send them to you for some dollars. No problem. Just give me an email if you want. Let's let it finish. Let me look if there is any additional question. I don't see it, so we can successfully close the simulation. Yeah, nota bene or reminder, such simulations, even though they seem easy at first, yes, when you look at the geometry. What can be easier than simulating these? When you start doing it, you can see the problems that arise during such simulations. So yes. Yes, dear spectators, we do have a nice beginning, a nice proof of concept. It should be extended with refinement, with longer solving time. And just for you, let me show to you on the pause. I would like to animate for you to see the rotation of the wheels due to the friction coefficient with the road. Let me save, and I will show you the rotation. Look here. Yes. So it began to rotate also here, where there are no obstacles. Yes. This is a rotation. It's a little wobbly. We can optimize the FEA with more trials, yes. So this is all from my side. Let me see if there is any other question now. Thank you for your attendance, and good luck in your simulation preoccupations, yes, and in your engineering or biomechanical, medical career. Bye-bye.